Okay, I guess with that we can start. First of all, welcome and thank you that you join us for the very last Shopware Deep Dive here today. And that for such a technical topic, caching, what matters. So we want to talk with you about the changes we did to the caching behavior in the 6.7 project line that will become the new default for the 6.8 major version, to give you already a heads up what you can expect and also already know which issues we addressed. One promise first, this is probably the only technical talk today where we don't mention anything about AI. So let's... So what is our goal for the session for the next 30 minutes? We want to explain you the concepts behind the new caching behavior and focus on giving you the understanding how the behavior is changing, what we did to give you also the tools to use the new caching as it is supposed to be used and to get the most benefit out of that for your custom projects. And also especially we want to focus on giving you concrete migration guidance so you know when you need to update or adopt your custom projects. As I said, we want to focus on the ideas and the concepts here. There's not that much code on the slides, but we'll have a lot of additional slides basically after the real deck with code references that we want to share later with you afterwards in Discord and so on. So when you see the PDF version, there's a lot of code and links that you can use as references. Maybe when you hear the word cache rework, you might already remember there was something last year already. So yeah, we did already a rework of the cache for 6.7.0. This is not what we want to focus on today in this talk, because what we did with 6.7.0 was already good. It relieved us of some real concrete bottlenecks. But in fact, what it also showed us was that as soon as we lifted those bottlenecks, we hit another wall, basically. We hit another wall with performance. And so we basically picked up where we left off with 6.7.0 and continued from there. We want to go through 5 concrete issues that we've solved with this cache rework. For each of them, we want to walk you through what was the actual problem there, how did we solve it, and for you probably most importantly, when and how do I need to adapt to this change. But first, it's not that we just addressed those 5 issues in separation. It all came together as a new kind of model how the caching works. And what our goal here was to really focus on HTTP standards and move it away from Shopware specific caching to a more of an HTTP standard caching. And also, all of what we talk about here is available already. It was released with version 6.7.7 already a while ago behind the feature flag. And you can activate the feature flag. We deem it production ready. It's just behind the feature flag because it might introduce some breaks. But you can already try it out, especially if you maintain shops that suffer from some of the issues we'll explain and we'll walk you through. You can already opt in for that and activate it. Otherwise, it will be default with 6.8. And also when you maintain store plugins, you can already check it out and test it ahead of time if you're affected and already prepare for the migration. So let's talk about the first issue, cache permutations, or better, the number of cache permutations. It was a real problem that in Shopware stores, there were just too many variants for every page that were stored into the cache. And then later on, they couldn't properly be reused, so the cache hit rate was rather low. The problem was with the cache hash. So the cache hash is basically the identifier that we use to identify the state you're running in and then differentiate between the cache pages and cache content that we deliver to you. Because when you switch language, you need to hit a different cache. When you switch a currency, you need to hit a different cache, because otherwise those kind of context-specific data is put into the cache. The problem here was rules can also have an influence on the cache or on the content. Therefore, rules need to be somehow part of the cache hash. But what we did before was that simply every rule that matched was part of the cache hash. And now it the number of variations per page grew exponentially. When you have 10 rules and all of them are basically independent of each other, you already have 1,000 of different variations per page that can potentially be cached. Then when you scale that to 50 rules, it's already basically uncacheable. So what we did instead is that instead of putting every rule ID into the cache, we just focused on the rule areas that really matter, because we already know in which areas rules are used. For example, when you use a rule, if a discount code or a promotion should be active, if a shipping method should be active, those are all kicking in only in the cart process when we are uncached anyway. So those don't need to be part of the cache hash. So by default now, we only include rules that are used in the product area. That is mainly for rule-specific pricing. Those are part of the cache hash. All the other rules are not part of the cache hash anymore. Of course, they evaluated, they work as before, they just do not fragment the hash anymore, the cache anymore. And here I have to say kudos to Max, who contributed that feature and basically got the whole thing rolling. So great, round of applause, he's here. So how do you need to adopt? Basically, when you've built features or customizations on top of our rule builder, you likely need to check those, because by default, then when rules that are used to manipulate or configure your feature, they won't be part of the cache hash automatically anymore. What we recommend you to do is use the rule area feature, where you can mark basically associations between rules and your feature as a specific area, and then there's an extension point where you can clearly say, okay, this area is relevant for the rule as well. That is, for example, what we did with our commercial plugin already, where you can display categories, products, and CMS pages based on rules, or hide them based on rules. We added those on a specific rule area. We said this rule area is cache relevant, and with that, it already kind of works with the new behavior. But also check really where your rules are used, because when you use them in a cart or in a checkout flow that's uncached anyway, you should not use them or mark them as cache relevant, because then again they will just fragment the cache and lead to a low hit rate. So the next issue then was that locked in states and fill cart states bypass the cache by default. So that means as soon as you're logged in or put something in a cart, you hit an uncached server. So you really feel kind of the difference in performance. That means for anonymous shoppers, everything was fine. Most of the time when the cache was warm, you hit cache pages for at least the most frequently visited pages. But as soon as you put anything in the cart and then get back to the homepage, for example, that should most of the time be cached, you run outside of the cache and have a really poor performance. That is especially true for B2B cases, where sometimes even the whole shop is behind a login. So a whole HTTP cache feature was not really usable for them. There were options already to configure this and to opt in and say, okay, even when I'm logged in, I want to have an HTTP cache. But the problem was, because the default was it was off, a lot of extensions suddenly relied on locked in states not being cached. And so you wanted, when you change the configuration, you basically needed to recheck all of your extensions. And the other issue with that was rebuilt in two states in the core, locked in and cart filled. If you have in your project something else, it was not really flexible. You could not really add something and fine-tune it to your needs. So in the beginning, it made sense to build it that way, because of the first problem with the huge cache permutations based on the rule system. Even if you would cache something in locked in states, the rule system kicks in, and effectively you have such a low hit rates that you probably barely notice the HTTP cache. But as we solve the permutation problem, now it also makes sense to start caching locked in states and fill cart. The one thing is, before it was pretty safe. There was no way that customer-specific state could somehow end up in a cache and then be delivered to other customers, because we just said, okay, that never happens. We'll bypass the cache anyway when you're logged in. But as I already said, that was pretty costly. So what we did was that we exactly flipped the behavior. So with 6.8, the cache by default stays active. And also, of course, all core routes that should be cacheable are marked as cacheable by default. And if your extension customizes that data, you now need to check that you don't put any customer-specific data in there, because otherwise it might be leaked to through the cache. But also the system now is pretty flexible, because you can manipulate the cache hash and you can dynamically also disable the whole caching when, for example, the state doesn't make sense to cache for you in your specific projects. So it's not just anymore with the two states that we built into locked in or filled card, but actually you can run any code and say, okay, in this case, at this hour, whatever, I don't need the cache, or you should bypass the cache. So you can really control the whole system there. So what do you need to do for adoption? You should really audit where you put personalized information into the HTML. So really look at things where you display card totals, where you display customer names, and so on. They shouldn't be part of cacheable pages. And the best pattern there is to actually load that private data asynchronously. So the big page can always be cached, and then you just load the dynamic data asynchronously. Also, as I said, you can opt out of the caching and you can still disable the caching, but that should only be the fallback. Only when you're really in a situation, for example, where you have really customer-specific prices, and you know for this customer, it actually really has customer-specific prices, then you can opt out, but not just for every customer, because maybe 10% of your customers have customer-specific prices. And the other thing is, when you manipulate or when you modify how the cache hash is computed, only add bounded variance to the cache hash. That is, for example, something like countries. When you have it, something country specific, you know what the upper limit of the number of countries that you support is. You can say, okay, I'll add 4 more dimensions to the cache because I support 4 countries. That is okay, but do not put, for example, customer numbers in the cache hash, because suddenly you have no idea how many customers you have, and suddenly every customer is running on its own cache. So that does not really make sense. Okay, and with that, I would hand it over to Andre to speak about Store API.
Thank you. So another problem we've taken care of is that Store API stayed outside of HTTP cache. Basically, as Jonas mentioned before, root level Store API cache was removed in 6.7 with previous rework. But at the same time, Store API roots were not marked cacheable for shared HTTP cache. At the same time, many read endpoints used POST, and POST is not cacheable by default. You can create workaround configurations for reverse proxies, but that's not a nice solution. As a result, Store API stayed origin heavy, and mainly price was paid by headless setups because storefront was still cached. So solution for that was to make Store API a normal HTTP cache citizen. We marked selected routes as cacheable in HTTP cache. At the same time, we added support for get method to most of API read endpoints. Behavior was or became to be transferred by headers and managed by cache policies. And also we reused existing already cache tagging mechanism to support automated invalidation for some of the routes. There was one specific case we had to take care of routes that support criteria. Criteria is quite a big object, and quite often it cannot be easily stored or transferred using query parameters. So we introduced underscore criteria parameter, which supports some kind of compression. How it's working or how to use it, you can see it in addendum slides. So what does it mean for you on practice? Here is a place where selecting right cache variant becoming a practical concern. Also, where the place where cache poisoning can become a problem. If you send back cache hash wrongly, you can get a wrong language, wrong currency, wrong price, or any other wrong variant. So at this moment, clients becoming some amount of responsibilities. First important one is send a swag cache hash back. If your client is supporting cookies, it's happening automatically because of some reverse proxy special configuration we added. But for other cases, you need to make sure to transfer that back in the header. Second one, to make cache working, you should prefer cacheable get method for all read requests where it's supported. And important thing to test all context, at least briefly, on your production systems, because that's where you need to make sure that you're receiving correct cache variants. Another problem was very limited cache configuration in previous version. Old config supported one global default TTL, which was applied basically to every page that was cacheable, both in storefront and store API. And there was two global configuration style while revalidate style if error. Other cache control directives were not configurable at all. Also, it was not possible for shop operators to override extension-defined TTLs where it made sense. And also, it was clear that there is a need for more granular TTL configurations. So we solved that with introducing named HTTP caching policies. So it's a set of configurations that named set of configurations that allows to define cache control directives. Then afterwards, it's possible to set those policies or assign those policies to different areas like storefront or store API for cacheable and non-cacheable routes. And all this basically relies on HTTP standards, so like cache control header and value header, and applies the same way to browsers, reverse proxy, CDNs, and Symfony cache. What you need to do for migration. First, get rid of removed parameters on the left side. Move those values that you need to the default policies. Also use this opportunity to check if some of routes need non-default but some special configuration with separate TTLs. And very important thing, if you are maintaining an extension, please avoid shipping additional policies without good justification, because that increases configuration surface for operators and maybe not so nice.
Okay. Then I continue with the last problem we faced, and that was magic configuration, or it's a reverse proxy. I'm not sure how many of you configured Varnish for Shopware and know how long the configuration is. Yeah, it's a bit. What we tried to do was, again, because we moved more to HTTP standards, really also use it on the reverse proxy side and really try to get the custom configuration that's needed down to a bare minimum. And now a working VCL literally fits on the screen. One thing first, we still have a pretty extensive Varnish configuration that does contain a lot more tuning also for serving static media assets and so on. But this is the kind of least amount of code that actually works. What you see here is basically two special cases that are needed for Shopware. The one is that we look into the cookies if you provide a cache hash via the cookie. That is just a nice thing that we want to do on the reverse proxy level to make it easier to build your clients, because we'll send the cache hash as a cookie from the application. That means when your client is a typical browser, it will send the cookie again to the reverse proxy automatically, so you don't need to adjust the cookie your client at all. And the second thing is that we have a special kind of cache hash value of not cacheable. That is when you dynamically opt out and say, hey, for this customer in these circumstances, the cache should be bypassed. You do it that way. So that is the two special cases that were needed. But yeah, also, again, I already said it, our real production grade Varnish configuration is still a bit more advanced. How were we able to do that, to trim it down? Basically by relying on HTTP standards, mostly cache control, as Andre already explained, and then also using the Vary header that is already supported by our reverse proxies. So Vary header basically is one header where you specify other header names, and as soon as the values of those headers change, you'll get another variation in the cache, and that is where we exactly added the SW cache hash. So that means the reverse proxy already sees a new value for the cache hash and knows that it cannot serve the old content anymore. How do you need to adapt? As Andre also already said, the SW cache hash, the values needs to go to the reverse proxy. For a browser, that is already done in a cookie. If you have a custom client, you might need to send that over. Then you should update your reverse proxy config. So is it our, for supported Varnish and Fastly configs, we already have new versions of the configuration that work with both the old caching behavior and the new behavior. So you have one Varnish configuration and you can toggle the feature flag on and off, and you don't need to care about configuring Varnish all over again. But we also have a 6.8 only compatible version that is then really trimmed down, and where you can really see that the Varnish configuration got smaller. Then one change that we also did is that the cache control with 6.8 will be delivered to the end browser as well. So that is the case where suddenly the browser can start also caching requests when you do not look at how you configure the cache control. That is something you should look at. But one great way as a smoke test that you can do to really see, hey, is my cache still working as expected? Would be to just create a product with rule-based pricing. Then you go first to the storefront, check that you see the correct price, reload the page, check that it is cached. Then you somehow make the rule true, whatever you used for the rule. Look that you automatically see the rule-based price without any magic or any special thing you need to do. And you also check that page is cached as well. And when you then change in the administration the price again, flush the delay caches, you should see that as soon as you reload the page, the new adapted price shows up. That is one simple, easy flow that already tests a lot of things for the reverse proxy. Tests that the hashing is working correctly. It tests that your cache control is configured correctly, and it also tests that the invalidation is working. So that is basically a bare minimum test you can do to check if everything works as you expect. Then for some design principles, how do we design cache-friendly extensions or also cache-friendly projects? The main point really is to load private data asynchronously and not put it into the main page request. So the idea, you can see that on the mockup in the right side, most of the page should still be cacheable, and then you only make the parts dynamic and load it asynchronously that really need to be dynamic. Then I also said already, when you manipulate the cache hash, when you add something to the cache hash and make it more dynamic, be sure that you know how much fragmented the cache will be by that change. So only put in values where you know kind of the upper limit to that, and never create customer-specific cache keys or cache keys that are really not hit that often later on. Yes, and with that, I would hand it back over to Andrei to walk you through the life cycle of a cache request.
Yes, thank you. So let's have a look at how normal cacheable request gonna be processed. So let's say browser asks for /home. Request hits shared cache, which receives a swag cache hash, either filled or it can be empty, which is also a valid variant, based on URL plus headers that are mentioned in the vary on the response or previous responses. It tries to look up for a proper variant. Then, if it's a miss, request hits origin, so Shopware. Shopware processes the root and applies policy, which is configured for it. Based on that, it sets on the response proper cache control header and vary header to set based on which request cookies variants should be selected for this response, and potentially, if there was recalculation, use the cache hash. Then response get returned to reverse proxy, which stores it and returns it to browser. Next request basically gonna hit reverse proxy and return it from there. This is a standardized HTTP behavior. We added a link to corresponding RFC in the addendum, and main idea is that it works for every reverse proxy the same way. Let's now discuss what is happening when something about user changes. So something about user changes means context changed. Not all context changes force a hash recalculation, as Jonas explained before, but here are the things that do. Currency changes, language changes, login, logout state change, card state change, or matching of a rule which is marked as cache relevant. So flow would look like this. Context changing request hits the origin. Shopware calculates the new hash. It sets on the response in the header and in the cookie both. Then when request and response as the cache hash differ, Shopware sets cache control to no store. So this is cache poisoning protection. Most of requests that actually causing cache recalculations, they should be mutating request and hit non-read endpoints, but if it happens for read endpoint, those not gonna be cached. and then next request carries the new hash, and reverse proxy uses it to select the proper variant. As amount of those cases where caches recalculated is limited, and we keep cardinality low, so this helps to keep cache less or more effective. If you want to change how caching behavior works, you need to know about next extension points. Resolve cache relevant rules ID extension mentioned previously by Jonas decides which rule IDs influence the cache, so you can change that. Then next cache hash required extension decides whether a cache needs to be calculated at all. So if not, the next event is not triggered, so it's for default context cases. Then next HTTP cache cookie event allows to contribute to the hash cache. It can mutate hash parts or mark whole session or only this request as not cacheable. And next one, HTTP cache key event, it allows to customize Symfony's HTTP cache key, but we discourage you to use it because it doesn't influence other caches. So what do you need to remember after today? 5 issues we've took care about, which need every of them needs some attention for migration. We have lower SV cache hash cardinality. We made login and field card traffic to be cached. Store API now uses HTTP caching. Policies replace global cache config, and reverse proxy follow cache control and vary headers. So we provide you with migration checklist here as a reminder for all things that you need to take care of, but also you can check the addendum after this slide, which contains exact code examples, configuration examples, detailed explanations, and so on. Yeah, so this is it. Thank you for attention.
I guess we are already over time for the last session. I would say we take the time and take 2 questions, and then all the other questions afterwards we are happy to answer to you in private later when you see us. Just talk to us or ping us in Discord or wherever. I know that Ollie already has a question.
You said that language. Hi. The second point on the left side, language change will not trigger a cache hash, right?
It will trigger a cache hash recalculation.
Should not be, because each language has its own URL. And when you just switching the language, you should not calculate the hash, because then you have a none hit or an anonymous hit and a changed hit with cookie and not cookie. Each language has its own domain.
That's true for storefront. We are talking for store API as well.
Yeah.
We can talk later about the special case you have.
Yeah, absolutely.
I
was just like, okay, no, please, because then you have 2 hits or 2 permutations, right? But yeah, we will talk about that later.
But I guess I understood your point. So when you're on a /com domain, you switch language to DE. You switch language to German. That means you also switch the domain to DE, right? So you get
but when I do this directly over the URL, I don't have a cookie, right? So I call .de, then I have no cookie, and I have cache hit 1. So then I switch to .com, then I have .com with hash, but when I just insert .com, then you have 3 permutations right now. For store APIs, this is required, yeah.
Okay, maybe one more question. You get a mic.
Oh, sorry. Thanks. You said when a plugin is adding some content that it needs to be loaded asynchronously, are you talking about a AJAX call getting the content and then putting it on the page, or can you also do some kind of easy tag for the thing to move it to a separately cached?
It depends on what you do in your plugin. You can do both. When you have something that is really dynamic, for example, think about customized product recommendations that really change on every page, and it always returns a different results. That should be an AJAX call. When you have something that is pretty static, for example, for the same customer, the ESI makes sense, or even just putting the HTML content in the client and save it on JavaScript side, and on page render, you'll switch the DOM elements. That could also be a pretty simple solution for that. But yeah, you could also separately cache content when, for example, it's customer specific. You have routes that show the customer information with, I don't know what you want to display there. It might make sense to have that separately cacheable when that repeats across multiple pages. So when you display something customer specific in a header or footer or wherever, that might make sense to cache that separately over ESI.
Just one moment, that ESI includes block the whole page load, while reverse proxy needs to receive or resolve those exact part. So you shouldn't overuse it, obviously.
Okay, then thanks for your time. Enjoy the closing session, enjoy the after party afterwards, and we'll see you there.